Okay, today's lesson is on chapter 10, making a new table of contents in your notebook, labeling it chapter 10. This is on area. Today's warm-up is what's here. You have a stage being set up for a concert. The stage is made up of blocks with tops that are congruent right triangles. So each block is a congruent right triangle. And if you notice, it's an 8 feet by 8 feet, the base and the height. They're going to put two of them together to make an 8 by 8 foot square. They want to set up a stage in the shape of an arrow. Draw a diagram of how the stage can be set up in the shape of an arrow with at least an area of 1,000 feet. So greater than 1,000 feet, but no more than, less than 1,400 feet squared. So each block is a triangle, and we should know the area of a triangle as base times height divided in half. So if I go ahead and plug in 8 times 8 divided in half, I get 32 feet squared for one block there. So I'm going to take my area and divide that by 32 for both. So here is it shown in the book here. I'm going to just enlarge this thing, select. So here's what they have in the book so we can see it. 32 is each triangular face. Divide the 1,000 by 32, you get 31.25, so at least 32 blocks. And then no more than 43 blocks for the 1,400 feet squared. I wasn't really concerned about the drawing that they have over here on the bottom right, but this was important. Being able to get that it was at least 32 blocks, and then at most 43. So today's objective for ELR 10.1 and 10.2, these are basic area formulas for a parallelogram we're going to go through: rectangle, triangle, trapezoid, kite, or rhombus. Some of them you already know, so let's keep moving on. All right, area rectangle. In the book, instead of using length times width, they use base times height. Parallelogram is the same exact formula as a rectangle. You just need to be able to locate the base and the height that it corresponds to for the parallelogram. So make sure you write both of those in your notebook. Now let's take a look at the examples. All right, so see if you could get A and B, and then we'll talk about what is DE to the nearest tenth. These are all parallelograms. So remember, you're looking at the base times the height here. Okay, so taking a look at A, the base is the 5, the height is in, the altitude is in the parallelogram, which is 4. We get 20 inches squared. Now take a look at B. This sometimes happens here. They don't put the height, the altitude in the parallelogram because of the way it's situated on the paper here. So here they have the height drawn on the outside, but it's still the height of this parallelogram. So it's 2 times 3.5, which is 7 centimeters squared. All right, so for this bottom one, what is DE to the nearest 10th place? First, we need to figure out the area. So if I was to rotate this parallelogram, the base would be 13. The height would be 9. Can you visualize that for yourself? If I turn it to the left and the 13 is on the bottom, that height would be 9. So what's the area of this parallelogram? It's 13 times 9, and we get the area to be 117 inches squared. But now they want to know, well, what's the height going the other way if I turn it the way it is right now, and AB is the base? This is the new height that I'm looking for, DE. Well, we know the area going the other way, which is going to be the same. So area is base times height. We got the area to be 117. My base for this height of DE is 9.4 times, we don't know what that is, divide over the 9.4, and I'm getting DE to be to the 10th place on my calculator. It says 12.4 inches. So just be prepared. Parallelograms can have 2 altitudes, 2 heights in it, depending on what base they're looking at. Okay, moving on. Triangle, I know we know this area already formula. Base times height, divided in half. So in this picture here, we have a sailboat. How many square feet of material will you need to make this sailboat? Pause the video, see if you can get it, and then come back. Okay, so for this one here, since they want it in square feet, to make my life easy for myself, I'm putting everything into inches. So the height is 146 inches. The bottom base is 160 inches. I plug it into the area formula. I get 11,680, and this is in inches squared, everybody. We need to change this to feet squared. So I know many of you think that you should divide by 12, but the correct answer is that you should divide by 144. So if you look over here to the right side, 12 inches is 1 foot, but I want to make it into feet squared. So that means I also have to square the 12 inches, which makes it 144. So you need to divide that by 144 inches squared. Those cancel out, and you get 81.1 feet squared. All right, here's a composite figure. You want to find the area of the figure below. Well, we have a square with a triangle here, so I can move this 8 up here. So this is 8 centimeters. And from here to here for this triangle, 14 minus 8 is 6 centimeters. Now I can find the area and add them up. Okay, my square is 8 by 8. My triangle is base times height in half. 8 times 6 divided by 2. Add those two up, I get 88 centimeters squared. Okay, here's something that if you were in class, you would do. So you would get a piece of paper, scissors, and a ruler. A next person would draw a trapezoid. So let's go ahead and just kind of draw one. You could draw one on your notebook. We're going to draw a trapezoid like this. We're going to label the bases as B1. Oops. I'm going to do it actually in the triangle inside. So there it is labeled. Now, what's going to happen is another person is going to make a mid-segment, which is a line parallel to the bases. So let me do this in red. Let's see, here's the midpoint, here's the midpoint. I'm making a mid-segment. What's going to happen is they're going to cut along this red line here, this mid-segment here, and they're going to get two pieces. And if they rotate it, I'll try my best to show you, we get this to be actually a parallelogram. So now I want you to think about it. The parallelogram area was base times height. Well, our base in this one is B1 plus B2. Our height is not the whole height, right? Because we cut it in half. So our height is h over 2. That's how you're getting the area formula for a trapezoid, for those that wanted to know visually using paper. So here it is. Half the height times the bases added up. So we're going to find the area of the state of Nevada. Okay, so if you pause it and put everything in the calculator, this is what you should get in square miles for the area of Nevada. All right, next one. Find the area of this trapezoid, and they want it in radical form. So that means we don't want decimals in our answer here. So let's take a look. We have a base here. We have our other base here. Well, what's missing is our height. So let's go ahead and sketch in the height. And if you notice here, I have a 30, 60, 90 right triangle. This is my height. How am I going to get this piece from here to here? Okay, well, we're going to subtract the 7 minus the 5, and I'm getting this to be 2 meters. And then if we follow our formula for the area, for the 30, 60, 90 right triangles, right? 30, 60, 90. This is 60, this is 30. We got this to be 2. So the one opposite of the 60-degree angle, which is our height, is 2 root 3, because this lovely thing, 2, is our x. So let's put this in the picture. Now let's plug everything in our formula. So when I do that, I got 2 root 3 over 2. My bases added up, 5 plus 7, so that's 12. I can divide the 2 by the 2 because those are numbers. And I get root 3. So I like to put the 12 in front of the root 3 there. So this is my area, 12 root 3 meters squared. All right. Find the area of this trapezoid. Again, think about it. We have to sketch in an altitude, a height. How do I figure that out? This is a 45, 45, 90 right triangle here. So the hypotenuse is 1.7, and it doesn't say how they want the answer, so we could have it as a decimal here. So let's just make a 45, 45, 90 here on the side so we could see it better. And we got the hypotenuse to be 1.7, and we know this is equal to x root 2. So to get what the height is, I would have to take my root 2 and divide it over. So I'm going to do this in the calculator because it doesn't say that it wants it, you know, in radical form. So 1.7 divided by root 2 comes out to be 1.2 about meters. See if you get the same thing. So that's my height. This is my bases, base 1, base 2. And I just realized I could have found the height by doing 2.1 minus 0.9, because from here to here, that was dumb of me, is 1.2, which makes this 1.2 also. But we still got the height. All right, so let's plug it in our area formula. Okay, plug everything in, do the parentheses first, division, multiply, get 1.8 meters squared for the area of this trapezoid. All right, last formula is the kite or the rhombus. All right, so again, they would do this on paper, but let's talk about, we could do it kind of visually by drawing it. So one person's going to make a square. Oops. So let's make a square. And then the second person is going to cut the square out. Third person is going to make a rhombus that fits perfectly in the square where the vertices of the rhombus are the sides. So let's do this in blue. So the vertices of the rhombus are at the midpoint of the sides. So let's put our midpoints on the square, and I'm going to connect it. Here is our rhombus inside the square. Now sketch in the two diagonals. So I'm going to do the diagonals in red. Here's one diagonal. Here's another diagonal. So it says discuss with your group. Remember, this is cut out now. The square is cut out. What would be the area for the rhombus? Well, it looks like if I could fold, this triangle would go onto this one. This triangle will go on here. This triangle will go on here. This triangle will go on here. So it's looking like a rhombus is still taking my length and width, but in the rhombus or kite, it's diagonal. So I'm going to say diagonal 1 times diagonal 2 in half is going to give me the area for a kite or a rhombus. So this is diagonal 1. This is diagonal 2. Here it is from the textbook. You can see there visually. Both for the kite and the rhombus, it's the same thing. Diagonal 1 times diagonal 2 divided in half. And let's try this problem here. It says, what is the area of this HOV diamond below? So let's see, what is missing? Well, we need this whole diagonal here. Well, we know this piece here has to be 2.5. Oops, let's do this in a different color. Let's do it in red. So this piece here is 2.5. So this whole diagonal, 2.5 plus 2.5, let's call it diagonal 1, is going to be 5 feet. We still need to figure out this side right here, which I'm doing in blue. How do I figure it out? Well, it's a right triangle. Let's do Pythagoras. Okay, so when I plug in my 2.5 as my leg, my 6.5 is my hypotenuse, because that's opposite the right angle. I work out my Pythagorean theorem, isolate that unknown, and do the square root. I get it to be 6, but again, we want the whole diagonal, so we're doing 6 plus 6, which is 12. So I have one diagonal as 5, the other diagonal as 12, so I'm doing 12 times 5, divided in half. 60 in half is 30, and this is feet squared. So that's the area of this diamond. All right, so hopefully you copied all those area formulas. That is it for 10.1 and 10.2 of geometry.